Complete combustion is a reaction where a fuel which contains carbon and hydrogen, so hydrocarbon, reacts with oxygen and oxidizes. So oxidation, the gain of oxygen. And so you can see here from this equation that the hydrocarbon, the hydrogen part combines with oxygen to create water, and the carbon part of the hydrocarbon combines with oxygen to make carbon dioxide, and that releases heat. So what we're going to do is try and mimic this diagram here, and we're going to burn a fuel, and it's going to hopefully, we're going to try and detect the water at the first bit and detect carbon dioxide. Now in this one here, we're also going to put another chemical in there to try and detect the water, and we're not going to use lime water in this case because I was repeating this one a few times, and it's much easier to reset it just with a acid-base indicator rather than a precipitation reaction, which is what happens when carbon dioxide goes through lime water. It goes milky from a precipitation. Carbon dioxide mixing with water forms an acid, and that we can just use an indicator that changes color when the pH changes. Okay, so if you just we look just here at the start here. So this one here, you can see the condensations here at the very start of the tube. So it starts to cool down, and the liquid gas, the water gas turns to water liquid. And down the bottom there, you can see at the start it's quite dry, and then at the end there's a little tiny bit of water that forms, so it's a slightly bluish color, but not much. So the white copper sulfate turns into the blue copper sulfate pentahydrate. So that's how copper sulfate reacts when it hits the water. And so it was easier to see the water condensating. Not in the right place, but that's fine because the system took a lot of tweaking. It wasn't running perfectly. Okay, the main reaction is this one here with the whole thing. Showing you the whole reaction all at once. So you can see that I think it was ethanol that we actually end up burning. The ethanol's burning there, and then it's first going through that U-tube, condensing, cooling to see the liquid, and you probably just missed it. It then bubbles through that conical flask, and now it's green already. You can just rewind it back and see that it was blue. And so that's getting bubbled through because at the very end there's a pump that's pulling the air through, and so you can see it also melts at the top there. Okay, so as I said before, the carbon dioxide mixes with the water to make an acid. The releasing of the acid then causes the bromothermal blue to go from blue to green, and then finally there is carbon dioxide and water in air. And so you would think that that this could possibly work without the flame. And so you should really run it like you can see here with no flame at all. And really, if it's cold, the water in the air should condense and the carbon dioxide in the air should make it go blue. And it probably would if you did it for an hour or more. Certainly, I ran out of patience before it did it, and it didn't. It certainly took a lot longer than a minute to work, whereas with the flame it only takes a minute. Okay, so that's just showing that it looks like the setup is flawed, but it works a lot quicker when there's a flame there.